All right, we're going to continue our study with conic sections. We're going to move to ellipses. This is section 10.3. Let's get started. First, we're going to talk about what is an ellipse. An ellipse is a set of points so that the sum of the distance to the two foci is constant. Let me bring up a picture. You've probably heard this called an oval in the past. Using that definition, we have some foci here. The plural form of focus is foci. We have two of them. And if I put a point x, y here on the screen, and I take that distance, I calculate it, and I calculate that distance, and if I add those together, it will be the same no matter what that x, y point is. So if I pick a new x and y point, and I find that distance, and I add them together, the sum of those two will be the same for all of them. There are some vocabulary words that you need to have. Before we get going, I want you to realize that you have note sheets. It is going to be very important that you write things down on these note sheets. We have a major axis. The major axis is always going to be the longest of these axes. At the end of that axis, we have two vertices. Here's our first vertex and our second vertex. It shows that that vertex is at a, 0. That means that the distance from the center out to those vertices is a distance of a. And it shows that the center of that ellipse is between the two vertices. We also have a minor axis. At the end of that minor axis, we have two co-vertices. On your note sheet, you have the word co-vertices right there. That co-vertex is at a distance of b from the center. The last thing we have on here is the focus. And the focus, you have two of them. We talked about those just a moment ago. Each of the foci is a distance of c from the center. Again, let's review everything we have here. We have the letter A is the distance to the vertices. B is the distance to the co-vertices, or co-vertex here. And C is the distance to each of the foci. It's going to be super important that on your notes that you write these out. We have two different kind of ellipses. We can have a horizontal ellipse and a vertical ellipse. Our horizontal ellipse has the A, B's, and C's, and then where I drew them before. The ones I'm going to talk about right now will have the center at the origin. Here is the general form of this equation. I want you to notice that the A, which is the major axis, is under the X. And that is because this is the x-axis if that's 0, 0. And A is on that axis. Your A value will always be greater than your B value. And to find that C value or those foci, here is the equation. This looks very similar to the Pythagorean theorem. We just have a negative in the middle. The next kind of ellipse is a vertical ellipse. Again, we're going to have our center at the origin. This vertical ellipse is going to be upright with the major axis being up. This is going to be on the y-axis because, again, this is at 0, 0 at the origin. I want you to notice that the A value, which is the largest one, if you remember, we said that A was bigger than B. Your Y value has the A under it. We still are going to find those vertices with the equation that looks very similar to the Pythagorean theorem, except that we have a minus there. The only thing that's changed on the two equations is the a and the b values. They've switched. The major axis is going to be under the y on this one, and the previous one it was going to be under the x. Now that we have all this information, let's do some problems together. This is number 1. We're going to identify the center, vertices, co-vertices, foci, length of the major axis, length of the minor axis, and then we're going to graph it all. Sometimes graphing comes first, other times it comes somewhere in the middle or last. You probably should take some time on your paper to write these words or some abbreviation for these words. So it might be time for you to pause this video and come back in a moment. All right, we're going to find the center. First, the center we told you was going to be at the origin. So it's going to be at 0, 0. Now we have some vertices, and we need to find our a values and our b values. So our a value is always the square root of the largest number in the bottom. So we have 36 and 9, and the largest is 36. So our a value is 6. That's what our general equation told us. I would suggest that you keep those note sheets out with those general equations on them. Our b value is the square root of the other one, which is the square root of 9, which is 3. All right, so our vertices, which I'm going to start graphing this automatically. We said that the center is at 0, 0, and then our major axis is a 6, and it's on the x-axis because there's an x there. So we're going to come out to 6 on the x-axis. And we're going to come out to 3 on the y-axis because our b value was 3. The reason it's on the y-axis is because it's under the y. We now have the edges of our ellipse. We just draw this and we try to make it curved as we go along. There's our ellipse, and if you remember, our vertices were on the corners. Our vertices are at plus or minus 6, 0. The co-vertices are the ones on the minor axis, and those are at 0, plus or minus 3. Our foci, we can use the formula a squared minus b squared equals c squared to find those foci. If you remember, a squared was the 36, and b squared is 9. So 36 minus 9 is 27. When I take the square root of both sides, I'll get the square root of 27. I can factor that into 9 times 3 and take a 3 out with that. So I will have 3 radical 3 as my foci. When I do this, I need to use my calculator to find out the estimate of that. Let's do that together. You do it on your calculator and come back. All right, I got 3 times the square root of 3 to be about 5.2, and that's on the major axis. The foci are always on the major axis. So I'm going to come out here and put a dot on about 5.2. It's pretty little in there because I can't go very far past the 5 for 5.2. All right, so the foci here, let's find the ordered pair that represents the foci. It's on the x-axis. So, and we went out both directions. We went out plus or minus 3 radical 3, 0. The length of the major axis is what we're going to do next. And the length of that major axis is right here. We know that this part is 6. That means the other part's 6. So it will be a total of 12. 12 units long. And the minor axis is this distance right here. So we know that that is 3 units and 3 units for a total of 6 units. I hope you noticed that the major axis is going to be 2 times that a value. And The minor axis is going to be the 2 times the b value. That'll always be true. We have graphed it and found all the information that they asked for. Now, we're going to be able to shift these graphs. We're going to be able to shift these graphs up and down and left and right. We have a center value of h comma k. On your note sheets, I left some blanks for you to fill in those squares. So you make sure you fill in those square values there. Now, there's a question at the top up here. Which one of these are horizontal and which ones are vertical? I want you to notice that the a value is in a different spot. The a value is on the x on one of them, and it's on the y on the other. The one that has the a under the x is going to be long on the x, so that one will be horizontal. This one will have the a value along the y, so it'll be long along its y. So it'll be vertical. I would suggest you write those down on your note sheets. Let's do one. We're going to find the same information and graph it. We're going to find the center, vertices, co-vertices, foci, length of the major axis, and length of the minor axis. Our center has now shifted. It's at these values right here. It's always the opposite of each of them. We have an x there is going to be -2, comma, +1. I like to draw that as I find it. So I'm going to come put this at -2, comma, 1. There's my center. My a value is always the square root of the largest one on the bottom. So my a value is 6 because it's got a 36 over there. Should be my b value is the square root of 4, which is 2. All right. So my vertices are going to be 6 units up and down because it's got a under the y, up and down from my center. So I'm going to go up 1, 2, 3, 4, 5, 6 for one of my vertices, and 1, 2, 3, 4, 5, 6 down from my other, we went up from the center and down from the center. You can write those now if you'd like. That is at -2, comma, and we got to find those numbers. This is here at 7 and at -5, so we're going to have to do 2 of them. My co-vertices are 2 to the left and to the right. We got the 2 from the b value, and it's under the x, and the x goes left and right. So we're going to go 2 this way and 2 this way. We're going to write those ordered pairs now. Let's write those ordered pairs for those vertices while we can. This first one is at 0, comma, 1. And the other one is at -4, comma, 1. Let's draw our ellipse. Try to make it curved. Try not to make it too pointed. All right. Now let's find our foci. We know our a and our b value, so we can use that to find our c value. Our a squared value is 36. Our b squared value is 4. We have 32 equals c squared. 32 is the same as 16 times 2, so we can take a 4 out from that 16, and we'll have 4 radical 2 because we're taking the square root of both sides. 4 radical 2, let's go do that on our calculator. 4 radical 2 is about 5.7. So 5.7 is very close to 6. And that's 5.7 from the center. So here we go. Let's go down. 1, 2, 3, 4, 5.7. And 5.7 up. 1, 2, 3, 4, 5.7. It's going to be very close. Okay? So the foci here, let's do this foci that's right here. It's at a y value of an x value of -2, and it's going to go up this direction, 4 square root 2 plus this little bit right here, this 1. And it's going to be 1 minus the 4 square root 2. So we're going to have, our foci is going to be -2, comma, 1 plus or minus 4 square root 2. Let's do the length of the major axis. The length of the major axis is going to be 6 up this way and 6 down that way. So it'll be 12. And the minor axis is going to be 2 this way and 2 that way, so a total of 4. We have found all our information and we've graphed our graph. Let's move on. This is not in our standard form. We're going to have to get it there before we can even find our A's and B's. We still have to find all of the other stuff that we found before. Let's get this into standard form. I'm going to start by moving that 360 over. So we will have 9x squared plus 8y squared equals 360. If you look on your note sheets, what's the number that's always right there on the last side? And that would be a 1. So to get a 1 there, we're going to divide by 360. But since we divided by 360 on this side, we have to divide by 360 on the other side. This becomes 1. And these simplify down. So how many times does 9 go into 360? Why don't you go ahead and do that on your calculator if you don't know. 9 goes into 360 40 times. So we're going to have x squared over 40. 8, it goes into 360 also, so we can reduce that to y squared over 45. That means our A value is the square root of 45 because it's the largest one. While our B value is the square root of 40. Now we can take some of those out. 45 is 9 times 5, and perfect square root is 3 for that. So this will be 3 radical 5. And 40 is 4 times 10, and that is a perfect square root of 2. So we're going to have 2 square root 10. All right, so let's start graphing. The center is at 0, 0, because we don't have any of the little shifts in our equation. It's just x squared and y squared. That's nice. We have 0, 0 as our center. We're going to go, is it going to be up 3 square root 5 or to the side 3 square root 5? Well, we need to look. That square root 40, that 45 was under the y, so it's going to go up and down. So we're going to come up 3 square root 5 or square root 45 and down. So we need to get a decimal value for that. 3 square root 5 is how much? Go ahead and put that into your calculator. When I did it on my calculator, I got 6.7. So I'm going to come up to 6.7, and then I'm going to go down 6.7. Now I need to get an estimation of that 2 square root 10. So you do the same thing, put it in your calculator, and come back when you're done. When I did it on my calculator, 2 square root 10 is about 6.3. That's very close to each other. 6.3 is there, and 6.3 on the other side is there. When we draw this, we're going to get something very close to a circle, because My two vertices are almost the same. We have 6.7 and 6.3. They're very close. Our vertices were up this direction. And so that was at 0, comma, plus or minus 3 square root 5. Our co-vertices were this direction, and that was at plus or minus 2 square root 10, comma 0. Our foci, we're going to have to use our equation to find that. If you remember, our equation is a squared minus b squared equals c squared. The nice thing about it is we have our a squared is 45, so we can just write a plain old 45. And our b squared is 40, and that equals c squared. That's going to be 5, and c is going to equal the square root of 5. And our foci come out on our major axis in this direction. You need to put that into your calculator and estimate that also. Go ahead and pause the video and come back when you're done. Square root of 5 is about 2.2, and it comes on the major axis, which is up here. And 2.2 is about right there, down below. And our foci, the ordered pair that goes with it, is 0, comma, plus or minus square root 5. The length of our major axis, we said, was twice our a value. What is 2 times 3 square root 5? Well, it happens to be 6 square root 5. And our length of our minor axis is this direction, which was 2 square root 10 each direction. And 2 times 2 square root 10 is 4 square root 10. We found all of our information. Let's go to something different. Now we're going to start working backwards. I am going to give you information and you're going to find the ellipse. We did it the forwards where I gave you the equation and you gave me information. And now we're going to need to know it backwards. If you can find information backwards, then you know the concept very well. They have given us the vertices and the co-vertices and asked us to find the equation. At some point, we might need A, B, and C. We might not need them all, but I'm just giving us some places to write here. I personally need to draw a little X and Y axis. I don't need it to be accurate. During class today, some people mentioned that it might be useful to have a piece of graph paper in front of them to use, or even a piece of graph paper that's put inside a sheet protector with a dry erase marker so they can erase it each time. 0, comma 11 is up here, and 0, comma negative 11 is down here. That's my vertice. That means my a value is 11. Then they gave us the co-vertices. The co-vertices are 4 and negative 4. That's out here. And that is our b value. Our general equation was x squared plus y squared equals 1, but where did the a and the b value? If you notice, my a value is going to be up at the top. It's going to be a vertical ellipse, so we're going to put that a value above the y. So we square that 11, it's going to be 121, and we square the 4, which makes it 16. We have found our equation. We did not need the c value for this. Let's do another one. This time we're given the vertices and the foci. I am going to draw it. So I have 0, 13 and negative 13. These are my vertices. That means that a is 13. And my foci are at 0, 12 and negative 12. This is my c value. So since it is going up, the vertices are up on that y, it's going to have an a value in front. I'm going to have an x squared plus y squared equals 1. And under the y, I'm going to have the 13 squared. You might need to do that in your calculator. You can pause the video to do that. It's 169, but we still have to find the b value. If I know a and I know c, I can find the b value by doing that inside my equation. A squared minus b squared equals c squared. A squared is 169, the b value we don't know, and our c squared is 12 squared, which is 144. We're going to subtract that over there and add the b value over there. 169 minus 144 is 25. Take the square root of both sides, and our b value is 5. We square that to put it on the bottom, which we really didn't need to take the square root. We needed the b squared value. That's fine. We got 25. Our equation has been found. Let's do number 17. This time we have a center, a vertex, and a focus. Because our center is at 5, -2, our equation starts out like this. X minus 5 squared, we don't know the denominator yet, plus y plus 2 squared, we don't know the denominator yet, equals 1. We will be looking for those denominators. I am going to draw an x and y axis. I'm going to put my center at 5, -2. I'm going to put my vertex at 0, -2, and my focus at 1, -2. Remember that the a value is the distance from the center to the vertex. From 5 over to 0 here, that is a distance of 5. My a value is 5. My c value is the distance from the foci to center, and that distance is from 1 to 5 is 4. So my c value is 4. Okay, we're going to find that b value by plugging it into the equation. A squared minus b squared equals c squared. That a squared, we're going to plug in the 5, make it 25, minus b squared that we're looking for. We're going to plug the 4 in for the c squared to make that 16. We'll move the 16 to the other side by subtracting, and we'll get b squared equals 9. At this point, we can just plug everything in. We can plug our a value in and our b value in. We're going to do the b squared. We'll make our a squared be 25, but we have to decide where it goes. Which does it go there? So we notice here our ellipse down here at the bottom is a horizontal ellipse. That makes it the large value go under the x. So our 25 will be here, which is the a squared, and our b squared 9 will go here. And that is our answer. We have covered ellipses. You have learned the definition of an ellipse. You have learned how to graph ellipses. And you have used all the information that you know to find the equation of the ellipse. I hope this has been helpful. Goodbye.